Okay, in number 1, they say, where is f of x greater than 0? We have a picture of f of x over here. And when you have a picture of something and want to know when it's positive, you are looking for where that graph is above the x-axis. That's what it means for a graph to be positive. That happens starting here at -5, x is -5, and continuing until right there when x is 0. So from -5 to 0, your graph is above the x-axis. And again, 1, 2, 3, when x is 3, it continues until x is 6. So we'll put a union there with the interval 3 to 6. In number 2, they say, where is the derivative positive? Well, the derivative is positive whenever the parent function is increasing. The graph that we see is the parent function. So we really need to figure out where is this graph increasing. And as far as we know, it's increasing from -infinity up until this relative max, which is at about, 1, 2, 3, I don't know, -3.5, -3.2, something like that. I'm kind of approximating it. Oops. So starting at -infinity and going to -3.5. And then the graph is positive again from this min to this max. The min's at about 1.5. The max is at about, oh gosh, I don't know, 4.8. So from 1.5 until about 4.8. If you have numbers that are reasonably close to these, you know, a few tenths off here or there, that's fine. Then for number 3, they say, where is the second derivative positive? Well, since we have a picture of the parent graph, second derivative positive means the graph is concave up. So it's opening up like a cup. That happens, and we got to kind of estimate about, like here we're definitely opening down like a frown, and somewhere in here, I don't know, let's say, just for simplicity, we'll say right about there, we change from opening down to opening up. And this continues to open up until somewhere, maybe in this ballpark, we have another POI. So I guess I would say somewhere from about -1 until a little past 3. Somewhere in that ballpark. Again, if you're a few tenths off here or there from what I have, that'll be acceptable. It's a bit of an approximation, a bit of an eyeball test.